We are. We have done the last of the tests. So there is a section, 11.7, called Strategies for Testing. And this is a very unusual homework because it's got 0 points. And it's there to give you practice at doing tests. And what makes this one a little bit trickier is that you won't be told which test to use. So we're going to look at how to tell by just looking at a series what would be the most appropriate test to use. Now, up to this point, you really haven't needed to do that. Haven't you been in a question where everybody was an alternating series, right? So that was a test. Or worst case scenario, it was one of two. Like it was either this limit comparison test or just a comparison test, or it was a ratio test or an end-through test, right? So we had those situations where you had a limited choice. Now, all bets are off. So I'm just going to randomly pick a series. Which of the 9 tests that are to the left is the one that you should use in this situation?
Ratio.
Correct.
Also,
Yes.
Is the telescoping series test technically a test? Because
Yes, it is.
Okay.
I missed one.
All right, because I wrote that down on my little card that I have of all the different tests. So
It's easy to miss one, isn't it? There's 10. I thought I'd got them all, but not. Now, what was it about this series that was the clue that you should really have went with a ratio test rather than any of the other 9 that you could have picked?
The n factorial.
Agreed. So that's probably one of the easier ones to do, right? If you see a factorial, top or bottom, I don't care where it is, think ratio test, okay? Now, how about a series that looks like this? Which of these tests would be the appropriate one to use if the series looked like that?
Alternating series test.
Agree. What was the clue?
The -1 to the n power.
Right. Agreed? Okay. Now, let's make life difficult. Which test should you use now?
Ratio.
Correct. Why the ratio test and not the alternating series test?
It has n factorial.
Right. It doesn't n factorial trump a -1 to the n. And by that I mean, if you try to do this with the alternating series test, you could prove that that has a limit of 0. I mean, it's pretty easy to do because n factorial is so much bigger than 2 to the n. You could just say it's obvious, and it would be. Could you prove that that is decreasing? Do you see the problem? How do you differentiate x factorial? Well, the answer is you can't. You see that you wouldn't be able to prove the second part of the alternating series test. So if you ever see a factorial somewhere, go for the ratio test. That's kind of out there. Now, What test would you use for that one?
It'd be the geometric series test.
I'm going to ask the same question every time. Correct. That's what I would use. Maybe a bit harder to say in English, but try your best. Why?
Just because it has that format of the A, R to the N.
It just looks, I don't know how to phrase this in good English myself. Doesn't it just look like a geometric series test? Doesn't it look like a geometric series?
It has
Right.
that shape.
Yeah, it's got the shape. What about that one? Anybody? What test?
The nth root test.
I prefer that name, so I'm glad you said it. The textbook just calls it the root test. Yeah. Tell me another test that you could use for that guy.
Alternating series. Because it's a negative to a power.
Yeah. Give me another test that you could use. There's one more.
Geometric.
Now, when you have a series that has 3 valid ways, all 3 of those techniques would actually work, right? They'd all get you the same answer. They'd all work. Which one do you pick?
The easiest one.
The easiest one. Now, the easiest one sometimes depends on you, right? For starters, the integral test is never the easiest one, right? So if you've got a choice and one of them's the integral test, it ain't going to be the integral, right? It'll be whatever the other choice is. Now, would you agree that if I did the nth root test in that, the limit would be 3/4 and it would converge? Would you agree that this is a geometric series test and the R value, once you take its absolute value, is 3/4 and that's less than 1, so it converges? So in this case, wouldn't you say that both those guys are probably equally easy? But for some of you, you might say, nah, that's easy. I can see that one in my head. I can do that really quickly. I'm not so comfortable with the nth root test because you have to do the nth root of the thingy and that gets me. Why would I not pick the alternating series test? Well, would you agree that there's a lot more work if you want to do the alternating series test? For instance, I would probably have to rewrite it. Like that. And wouldn't I have to then prove that that guy tends to 0? And wouldn't I also have to prove that that guy is decreasing? And in other words, don't you have to find a derivative and a whole load of stuff? Would you agree there's just a lot more work in an alternating series test in this question than there would have been for the other 2? So if you have a question and it just says, does this converge or not? Would you agree that you may find situations where there are 3 possible choices? Now, would it be wrong to do the alternating series test? No, you'd eventually get the same conclusion as the other 2. Wouldn't be wrong, right? You get the right answer, but you can imagine it would take you longer. So that's part of the kind of thing that you do when you're making your mind up about what to do. What test would I use for that series?
E-series.
Red? Want to tell us, Eli, why, and I'll give you your 10 points back.
Because it's the n to the third, p would equal 3.
Yeah, it hasn't it got, for want of a better word, doesn't have the shape that a P series has. Like, you remember that, I think it was Kira did. It's kind of hard to explain why you know it's a geometric, but isn't that what geometric series look like, right? isn't this what a P series looks like, right? No. So I'm going to have to get my pen system worked out there. What would you use on that series?
The alternating series test.
And would you agree that the clue there is that -1 to the n?
Yeah.
Now, what would you use on that?
Limit comparison.
Correct. Why the limit comparison test?
Because it's comparable to a P series.
Right. What would you do with that one?
Is the comparison?
Yes. What was the clue that this was a comparison, but that was a limit comparison?
The sign in the numerator?
Right. So e to the n, e to the 1 over n, right? Sine squared, inverse tan, you know, I call them weird stuff, right? If there was a weird stuff on the top, right, but this is in the bottom, you should do the comparison test. But I could change this a little bit. But if it's, you know, polynomial over polynomial, right, as it is here, wouldn't you do the limit comparison test? Tell me 2 different tests, any one of the 2 you can think of, that you could use in that situation.
You could do the limit comparison test on it.
Correct? Because basically it's a bit like that, isn't it? Now, can you see the other one? Because it's kind of well hidden. And Matthew kind of touched on this earlier.
Divergence test?
No, if that was n squared, I'd agree with you. Actually, that's what my next question is going to be, but forget about that. No, that won't work. Not this time. There's a clue in the way the bottom was written. And it's one of these guys.
Is it a telescoping series?
It is. And aren't you going to have to do the cover-up method to get it into 2 separate fractions and do all that stuff? Remember it now? So it's going to be, who knows, 4 over n plus 1, take away 4 over n plus 2, you know, that kind of thing. And then you write down 8 or 9 terms and everybody dies except somebody at the beginning and somebody at the end, and then you get your conclusion, right? Now, since there are 2 choices here, if you were allowed to pick any method you want, which of those 2 choices would you choose? Which is easiest? Yeah. Would you agree the limit comparison test is better, less work than the telescoping series, right?
Yeah.
So that would be your choice. If they allow you to pick one, right? If the question just says, does this converge or diverge? You know, you're going to show me, you know, in the midterm, the working, but in this case, you could just do your quick, or you go through and get the answer. Now, someone did kind of jump the gun, but it was a good question, so I'm not going to waste it.
I have one quick question on the telescoping series.
Yes.
On something like that, do you know it's going to be a telescoping series just by looking at it, or do you have to do the cover-up method and see if you find a negative in the second term?
Yeah, if you see a fraction over 2 guys, the telescoping series will work. So
Okay, cool.
they're all going to work. I wouldn't want to do half of them because the numbers would be so horrendously ugly and messy, and you know all the things you have to do. But it would work. You would eventually get it. So that, if I'm picking you up correctly, if someone gave me, let's just focus on some telescoping series for a minute. If you told me that it's a telescoping series, if you told me that it's a telescoping series, the only difference is that this gets converted into version like that. And this always, I'm saying always, I'll take that back now, I can think of exceptions. You will do the partial fractions, and if you get the same number at the top and a minus in the middle, then you've got a telescoping series. You could easily get a situation where that's 6 and that's 2, in which case the telescoping wouldn't work. Now, this guy is not a telescoping series. What method could you use? Oh, and the reason I know it's not is because there's an n squared in the top and an n squared in the bottom. And for a telescoping series to work, shouldn't the top be smaller than the bottom as far as powers go? What method would you use for that one? And it's in the list. And somebody about 5 minutes ago actually mentioned it.
Divergence.
It's a divergence test. Now, I could do a limit comparison test, and it would work. But I would say the divergence test is quicker. Would you agree that you could FOIL out the bottom and prove that the limit was 10? And because the limit is a number, it diverges. That's what a divergence test says. Limit comparison test would take a lot more work, and it would eventually tell you the same thing. It would behave like a number actually, so that's a bit weird, but it would work. How about, I'm not done. I've done. I'm trying to think of what I missed. Okay, oops.
Is there one where we're going to be penned into doing the integral test? Like what would that
Yeah,
be compared to the others?
Thank you. I'm trying to remember which ones I haven't given you an example of. So you are all now going to know that this is the integral test. So that is not going to be a choice. And the integral test will definitely work. What other test could you use for this situation?
Limit compare.
Make comparison.
Agreed. Which one will you use if you have that choice?
Limit comparison.
End of story. Right. How about this one? What method will you use for that one?
The direct comparison test?
Nope. Keep thinking.
Does that one have to be the integral test?
Yeah, I can't see a way to avoid it in that one. Now, if you try to do a direct comparison test, or even a comparison test, you know, if you want to call it that, or a limit comparison test, do you know the big problem is, who do I compare it to? You agree there's not a P series in the universe that looks like that guy? And that's caused by the E into the 4 thing, isn't it? It is bad news. I'm thinking, could I do an n-through test on it? N to the 4 would kick off an N. Yeah, I could. Yeah. Now I'm thinking about it, you could do an n-through test on it. Be really ugly, but you could do it. Any more combinations? Yep, done those, done those, done those. Done. Okay. So we're now going to look at the homework that has 0 points. Because it's got 0 points, you could end up not doing the homework at all and get 0 points. Or you could do all of the questions perfectly correctly and still get 0 points. So it's here as a resource. It's here to give you some questions. What they ask you to do is converge or diverge. In other words, not only do you have to pick the right test, you have to then go and do it, and your final answer is just going to be converge or diverge, as you'd expect. See if I can make this a little bit bigger. Right, are you looking at 11.7? Okay. So, what you doing, Celeste? Chloe was caught chewing something. She should the doghouse, literally. Okay. If you were going to do 2 to the power of n over n, what method would you use?
Ratio.
Yes, and that would work. And it would diverge. I'm telling you that, but it would work. What other method could you use in question B?
Like the L hospital.
Well, the reason you're doing L'Hopital, I'm assuming, is because you're doing the divergence test, and it would end up having a limit infinity. Question 2A. Right, so I want you to think of not just any method, but what you think would be the least amount of work method, which makes it a little bit harder to pick sometimes. What would be the least amount of work method for E?
I would choose the limit comparison test. I like that
would,
one.
I would agree. What about, I think B is a no-brainer, but I hope it is a no-brainer for you as well. What test would you use for B?
The nth root.
Nth root test. Isn't that ugly thing to the power of n the giveaway? Right? Or ugly thing to the power of n squared, or ugly thing to the power of 2n, right? The guys that look like that, and doesn't the nth root test work really well with that? And that one converges, by the way. What about that ugly one? Number 3.
Limit comparison again.
Yeah. What would you compare it to? What would that simplify down to?
1 over n.
And doesn't that diverge? So can you say in this question, if you weren't doing working, wouldn't you just pick that one, right? But get into the habit of practicing the method, because I keep harping on about this. Become the midterm, I don't care if it converges or diverges. I just want you to see the proof. If I don't see the proof, it's not good to me. Well, this one's a bit messy. What would you use in question 4? What method?
Alternating series test.
Correct. What's your gut feeling? Converge or diverge? Just by looking. Hopefully you've done enough that you start getting a gut feeling about them. What do you think, Mia? Converge or diverge? Don't know if you can hear me. Mia? Oh, I'm saying, where do you want to go? If you say, I'm guessing, and then say it, that's fine. What do you think? God, I would never take you to a restaurant. I'd starve to death before I picked dinner. Come on. What are you guessing?
Yes, converging.
Good answer, it is. Do you know you can actually tell by just looking at the fraction? Do you see that that fraction is decreasing? Right? It would get smaller and smaller. And the minute I see it decreasing, I know it's going to work. Right. Oh, here's a good one. What would you use, anybody now, in question 5? What? Which? I can quite catch it, Eric, would you say?
Ratio?
Yeah, ratio would work.
Or couldn't it be direct comparison test as well? Or would that be not it?
Who would you compare it against? That's the problem.
Yeah.
So no, it wouldn't be the short answer, but you know, think it through. Sometimes you have to say it and then think it through before you say, okay, I won't do that after all.
I had a
What? Mhm.
series.
A bit louder again.
I had
Yeah.
a alternating.
If we're talking question 6 now, I agree, alternating series test.
No, I mean, like, I was wondering, to show that it's like decreasing.
You find the derivative is negative. So you find the derivative of e to the x over x squared and then prove that it's negative. If you see some of the notes, all you basically do is differentiate it, factor the heck out of it, and then just prove to me by saying the top bit's plus and the bottom bit's negative, so it's negative. That's kind of what happens. And so if the top bit was n squared, that would be positive. If the top bit was 1 minus 3n, that would be negative, you know, those types of things.
I think I forgot. That makes more sense.
Okay. What about question 6? What method for question 6? I think this is a no-brainer.
Alternating series.
Agreed. Nobody should disagree with that. It's not guaranteed, but the minute you see this minus 1 to the n, minus 1 to the n, minus 1, isn't it, you know, at least 90% chance of being a geometric series test? Or it might occasionally be a ratio test. That would be the other possibility. And the ratio test would work here as well, if you said that. This one, really, there's only one right answer, although I wouldn't want to do it just because it's so damn ugly, but there's only one real method for solving question 7.
It would just be
Ratio
a ratio test. Yeah.
Yeah. Would you agree that is going to be one heck of an ugly ratio test? But that would be the test that you would choose. I can look at that guy and I can tell you it's going to converge. Anybody get any ideas how I know that that would end up converging? And I haven't done any of the proof.
Because the bottom will expand a lot bigger than the top will.
Yeah. When you're doing a ratio test and there's an n factorial involved, wherever the n factorial is pretty much decides the answer. Because n factorial is huge compared to most things with one exception. So in this case, n factorials in the bottom means it's going to converge. If I took that fraction and just turned it upside down, right, put the 2n factorial on the top and the other stuff in the bottom, that would definitely diverge. Now, I said with one exception. What's the only thing in the universe that's even bigger than an n factorial?
And n to the power of n.
And if you see an n to the power of n, won't you be, in that case then, wouldn't where n to the power of n is decide if it's going to converge or diverge, right? Because n to the power of n is even bigger than n factorial. Right? I wouldn't want both of them to be together in the same series, because then the method would be the ratio test and a really ugly one at that. If I have time, we'll actually do it as maybe our last question. We'll see if I have time.
N to the power of n factorial.
Ah, we going there then? Yes, technically, that would be correct. That would be even uglier than them. But with the basic building blocks, because if you're going to go that way, how about n to the power of n to the power of n to the power of n factorial? Right, I mean, you could just keep doing it. Right?
N factorial, factorial, factorial.
There's another one, right? Question 8 technically isn't one series, isn't it really 2 series? So what you should do if you were doing question 8 is break it into 2 distinct parts. A 1 over n squared. Let's talk about that first then. What test would you use for a 1 over n squared?
P series.
P series converges. What test would you use for the 1 over 2 to the n?
Ratio seems like would be pretty easy.
Ratio works. I agree, and it would you get the right answer. I would do something different, but that doesn't make you wrong, does it?
Could you do a divergence test?
I wouldn't in that one because you end up with 0, and 0 means you don't know. Sometimes,
Okay.
right. But what about 1 over 2 to the n? There's another guy you could use.
Geometric series, I think.
Yeah, because it's really a half to the power of n, so that's the R value. I don't think 9 should cause problems. Pretty obvious what method, what test.
Ratio test.
Agreed. Jade, what made you pick that?
Because of the n factorial in the denominator, just mixes everything and makes a
Yeah.
ratio.
Yeah. Last one, and then we will have time to do that horrible one and call it a day. What would you do in this case? What would be the test?
Alternating series.
Yeah. In this case, isn't the clue that -1 thing again? Well, I hope after just going over them, you're beginning to get a better feel for what tests go with what kinds of series, right? It's a kind of an experience thing. The more you do, the better you get at it. But we got a kind of feel for it. Now, in the test and in the homework, don't they just ask if does it converge or diverge, right? So in those cases, you can pick any test you like. But in the midterm and in the final, you will get 2 kinds of questions. The first kind will be use the integral test on this series. And the minute I tell you use blah, blah test, you have to use it. Even if you say, but I could do an nth root test on that and get the answer in 10 seconds. The reason you're being asked is not because I want to know the answer. I want to know, do you know how to do the integral test? And do you know how everybody avoids doing it? Sometimes you have to make them do it by telling them to use it, right? And then the second kind of question is kind of better in a lot of ways, and it's similar to what we've done right now. Couldn't I just give you a series and say, find out if it converges or diverges and pick whatever method you feel like, right? So if there's no instructions about which method to use, you are allowed to choose any method you like. Now, when you're doing the test, like the online test, you won't necessarily know what section a particular question came from, right? So pick whatever method works for you. Unless the question, I've seen some of the questions where they're phrased in such a way, like, tell me who EN is, tell me who EN plus 1 is, and tell me what the limit of EN plus 1 over EN, right? No, if they do it that way, aren't they making you do the ratio test, right? But in general, if they just say, does it converge or diverge, you are good to go. In the midterm and the final, you got to do what you've been asked to do, unless otherwise. Right, that's a really horrible way of writing that. Let me rewrite it. For our final question for today, I thought I'd pick a really ugly one, which is that one. And because it's got an n factorial on it, you can't really, you don't need to choose. It's going to be the ratio test, right? Bottom line, it's going to be the ratio test. You can't really do any of these other tests. The n factorial just either has no chance of working or just doesn't work, right? For instance, finding the nth root of n factorial. Would you agree nobody knows what that is? You can't even figure it out. So that's why that gets kept out. And none of the others fit that category. So taking it nice and slow. An is that guy. En plus 1 is n plus 1 to the n plus 1 over n plus 1 factorial. Are we good? So the limit as n tends to infinity of the absolute value of this guy divided by that guy becomes the limit as n tends to infinity. And since these are all positives, I can do away with the absolute value part. And I'm going to do n plus 1 to the n plus 1 over n plus 1 factorial. And on the bottom, n to the n over n factorial. I'm now going to turn this upside down. So it's going to be n plus 1 to the n plus 1 over n plus 1 factorial times n factorial over n to the n. So far, so good. Right, is anything on the top going to cancel nicely with anything on the bottom?
Won't the n factorial cancel?
What's going to be left behind when an n factorial fights with an n plus 1 factorial? What's going to be left?
The n plus 1 on the denominator.
Correct. So I'm going to have that guy. I'm going to have that guy. And I got that guy. As I say, I'm taking this a lot slower. You don't need every one of these lines, but I want to take it slow. Now, forget about this for a little while. N plus 1 to the power of n plus 1 and n plus 1 single power. They cancel. What do you get?
N plus 1 to the n.
Would you agree that you just lose one of the n plus 1s? That makes sense? Now, this guy can be rewritten in a nicer way.
You can combine all of it into the power of n, which actually I'm kind of stoked about because that's a really clean thing to happen in this.
It is, isn't it? Now, the thing inside the brackets, which is this guy, can be rewritten in a way that's going to make this a lot nicer to work with. How would you rewrite n plus 1 over n?
1 plus 1 over n.
Do you see why we're doing that? Why it's going this way? Isn't this a guy that I just called magic? And I said, trust me, this is what this is equal to. What does this get you? E to the power of 1, E, right? Oh, wait a minute. Isn't E a number that's bigger than 1? Agreed? What conclusion do you get if the ratio test has a limit greater than 1? What does it tell me about this series?
It diverges.
Are we comfortable with it? So you can do the ratio test even with ugly combinations of n to the n over n factorial. In a way, didn't we already predict that? Isn't n to the n massively bigger than n factorial? And so can you imagine that that's basically just going to disappear to some ridiculously big number, at least in the long term. And it's going to diverge because of that. Are we good? Right. I think that is us for today. I don't see any point in just ranting on because I can. So I'm going to hang about. So that means I've got plenty of time now to help you with any homework questions or any problems. And goodbye. Have a nice weekend. And I shall see you on Monday, where we will be looking at the power series. Okay, bye-bye, guys.
Have a great weekend.
You too. Bye-bye, Kira.
When will the test be available?
1 o'clock today.
Okay. Thank you. Have a good weekend.
You too.
Thank you. Have a good weekend.
You too.
Mine says it's already available.
Say that
Yeah.
again, David.
Mine says it's already available.
Is it? Okay, then I made a mistake. You don't want to go there, right? Don't go in until you're ready to do it. I thought I'd set it up for 1, but I bet you I set it up for 1 a.m. when I thought I'd set it up for 1 p.m. No biggie, because it's available when you need it. You've got all the way to Sunday anyway, right? Midnight.
It says Friday next week.
What?
David, stop telling him.
No, tell me. I'm going to find out what I screwed up here. What the heck did I do? Okay, let me go in and reschedule that guy. Online test, you're right. Whoa, that was a weird one. Right. And I did put it as AM. So now I will put it as PM. It'll still be available later today, right? And this thing should be changed to 2. Okay, tell me, update it now and tell me that it now has disappeared. Right. Okay, it will reappear at 1 o'clock as it was meant to. Okay, who's want to start? Who's got the homework questions or whatever questions they have?
I
Yes,
had
Ben.
more of like a general question. So
Mhm.
for like the equation 1 over n, isn't the summation of that from like n to like infinity, isn't that like divergent?
Yes.
Why is that? Because isn't the limit of like 1 over n 0?
Yes. Strangely enough, just because the individual terms are 0 doesn't mean that the series will converge. So let's do the 1 over n guy you're talking about. It's called the harmonic series. So if you plug in the numbers, this is what the series looks like. And you are saying, quite logically, well, look, that gets tinier and tinier and tinier, and the limit is 0. So surely adding up all those terms would be a finite number, right? Logic seems correct, but it's not. So this is not a full proof, but this is one proof, just doing it by numbers. If you group the next 4 fractions together, they add up to a fraction that is bigger than a half. If you group 4, if you group the next 8 fractions, it adds up to a fraction that's bigger than a half. If you then group the next 16 fractions, it ends up being a fraction bigger than a half. Since there is an infinite number of these terms, can't I keep just doubling how many terms that I need and still get a sum bigger than a half? So what you've really got here is 1 plus an infinite number of halves, and this is infinity. So that would be one way of kind of numerically trying to convince you that the answer to this is in fact an infinitely large number.
Interesting. Is that like the only one which we really have to worry about it being like misleading like that? Or?
No, actually there are thousands of the bloody things. So the problem people have, actually theoretically there's an infinite number of them, because couldn't I just stick another number at the top and that would diverge, right? They don't even need to look like that, right? That'll diverge, even although the limit of the individual terms is 0. The other way of proving that this is to do an integral test. Essentially, the log of infinity, take away the log of 1, and isn't the log of infinity infinity, so it diverges. I've cut out a lot of the middlemen, but I could prove that 1 over n diverges just by using the integral test.
That makes sense. So then for the divergence test, if the limit is 0, that doesn't tell us anything?
Correct. It means it's inclusive.
I think that's
right. So that is a common mistake. The divergence test only tells you when things diverge. If the limit is 0, it doesn't tell you one way or the other. It's inconclusive. Actually, if it had been true We wouldn't need the other 9. Wouldn't we just do the divergence test for everybody?
Yeah, that makes sense.
And
All right,
that-
thank you. That makes sense. Appreciate
okay.
it.
Okay, what's the next one? Who's got a question? N equals 1 to infinity. And it's -1 to the power of n minus 1. It's n to the 4 over, in my case, 9 to the n. You might have slightly different powers, but that's the gist of it. Does that look familiar? And so we are going to be looking at this, and I'm saying that this one is a ratio test rather than an alternating series test. Now, could I do the alternating? Yeah, but it'd be a really ugly thing to prove that it's decreasing for starters. Actually, it'd be pretty ugly to prove that its limit was 0. So if you do an plus 1 over an, and you find the limit as n tends to infinity, it becomes the limit as n tends to infinity of -1. If you add 1 to that, you get n, and then you get n plus 1 to the 4 over 9 to the power of n plus 1. That's what the top looks like. And the bottom looks like this guy. And what I'm going to do next is basically they cancel out. It doesn't matter what's left over, because it's only going to be 1 or -1, and the absolute value kills that. So that means that I can really just focus now on that guy over, that by the way is a 4, that guy over that guy. And I'm going to look for things that can cancel. And that guy cancels with that guy and leaves a 9 on the bottom. So I now have n plus 4 to the 4 over 9 lots of n to the 4. And I could FOIL that out, and eventually I would get to, something I could deal with. Since they are both powers of 4, I'm going to call this n plus 4 over n to the power of 4. Just a different way of tackling it. The first way of tackling it is just foiling that out, and I don't want to because that's a lot of work, but I could. And if I did, couldn't I then do L'Hopital or divide top and bottom by n to the 4? And the answer I would get is a 9th. Now, if I do it this way, I get 1 plus 4 over n to the 4. I can now do brute force. It's 1/9, 1 plus 4 over infinity to the 4. Now, by the way, that is not e to the 16. It looks like it could be, but isn't it just a 4 there, not a 4n? Right? If that was to the power of 4n, it would be e to the 16. But because that's a 4, you see it's just a 4. So I get 1/9 times 1 plus 0 to the power of 4, which is 1/9 times 1 to the power of 4, which is still 1/9. And since this number is clearly less than 1, we have here an absolutely convergent.